Hello? Welcome. In this video, you will listen to texts from a 1 to C2 level. Each text becomes more challenging, helping you improve your English step by step. Enjoy learning and see how far your English can grow.
Agronomy, A1 level.
Agronomy is the science of growing plants and improving farming. Agronomists help farmers produce healthy crops and use land in a good way. They study soil, water, plants, and weather. Farmers grow many crops, such as wheat, corn, rice, potatoes, and vegetables. Good soil is very important for plants. Agronomists check the soil and help farmers choose the best crops for their fields. They also recommend fertilizers to help plants grow stronger. Water is another important part of farming. Plants need enough water to grow well. Farmers use irrigation systems when there is not enough rain. Agronomists help farmers save water and use it efficiently. Weather can affect crops. Too much rain, strong wind, or very hot temperatures can damage plants. Agronomists study weather conditions and help farmers protect their crops. Modern agriculture uses technology. Farmers use tractors, drones, and computers to work more effectively. New technologies help farmers grow more food and reduce waste. Agronomy is important because people need food every day. Thanks to agronomists and farmers, we have fruits, vegetables, grains, and other products. Their work helps provide food for people around the world and supports sustainable agriculture for the future.
Agronomy, A2 level.
Agronomy is an important branch of agriculture that focuses on growing crops and improving farming methods. Agronomists work with farmers to increase crop production while protecting the environment. They study soil, plants, water, and climate to find the best ways to grow food. Healthy soil is essential for successful farming. Agronomists analyze soil quality and recommend suitable fertilizers and farming techniques. They also help farmers choose crops that grow well in specific regions and weather conditions. Water management is another important part of agronomy. Crops need the right amount of water to grow properly. In areas with little rainfall, farmers use irrigation systems. Agronomists help design efficient irrigation methods to reduce water waste and improve crop yields. Pests, diseases, and weeds can damage crops and reduce production. Agronomists develop strategies to protect plants using safe and effective methods. They often recommend crop rotation and other sustainable practices to keep fields healthy. Modern agronomy uses advanced technology such as drones, satellite images, and computer software. These tools help farmers monitor crops, identify problems early, and make better decisions. Agronomy plays a key role in feeding the world's growing population. By improving agricultural practices, agronomists help farmers produce more food, protect natural resources, and support sustainable development for future generations.
Agronomy, B1 level.
Agronomy is a branch of agricultural science that focuses on crop production and soil management. It plays an important role in ensuring food security and supporting sustainable farming practices. Agronomists work closely with farmers to improve crop yields, protect natural resources, and increase the efficiency of agricultural production. One of the main responsibilities of agronomists is to study soil conditions. Healthy soil is essential for plant growth because it provides nutrients, water, and support for crops. Agronomists analyze soil samples and recommend fertilizers or other treatments to improve soil quality. Water management is also a key aspect of agronomy. Crops require the right amount of water to grow successfully. In regions where rainfall is limited, farmers rely on irrigation systems. Agronomists help develop effective irrigation strategies that reduce water waste and maximize crop productivity. Another challenge in agriculture is protecting crops from pests, diseases, and weeds. Agronomists research different methods of crop protection, including biological and environmentally friendly solutions. Their goal is to reduce crop losses while minimizing the impact on the environment. Technology has become increasingly important in modern agriculture. Farmers use drones, GPS systems, sensors, and data analysis tools to monitor crop health and improve decision-making. These innovations help increase efficiency and reduce production costs. Agronomy is essential for meeting the food demands of a growing global population. By improving farming techniques and promoting sustainable practices, agronomists contribute to a more secure and environmentally responsible agricultural system.
Agronomy B2 level.
Agronomy is a multidisciplinary field of agricultural science that focuses on optimizing crop production, improving soil health, and ensuring the sustainable use of natural resources. As the global population continues to grow, agronomy plays a crucial role in addressing food security challenges while minimizing the environmental impact of agricultural activities. One of the primary objectives of agronomy is to improve crop productivity through scientific research and innovative farming practices. Agronomists study plant genetics, soil chemistry, climate conditions, and nutrient management to develop effective strategies for increasing agricultural output. Their work helps farmers achieve higher yields while maintaining the long-term fertility of their land. Soil management is a fundamental aspect of agronomy. Healthy soils provide essential nutrients, retain water, and support plant development. Agronomists assess soil properties and recommend practices such as crop rotation, cover cropping, and balanced fertilization to prevent soil degradation and enhance productivity. These methods contribute to sustainable farming systems that can remain productive for future generations. Water management is another critical area of agronomic research. Agriculture is one of the largest consumers of freshwater resources worldwide. Therefore, agronomists work to develop efficient irrigation techniques and water conservation strategies. Precision irrigation systems, for example, allow farmers to deliver water directly to plant roots, reducing waste and improving resource efficiency. In addition to managing soil and water resources, agronomists focus on protecting crops from pests, diseases, and environmental stresses. Integrated pest management combines biological, cultural, and technological approaches to reduce the need for chemical pesticides. This strategy helps maintain ecosystem balance while safeguarding agricultural productivity. Technological innovation has transformed modern agronomy. Advanced tools such as drones, satellite imagery, artificial intelligence, and data analytics enable farmers to monitor crop conditions in real time and make informed management decisions. These technologies increase efficiency, reduce costs, and support more sustainable agricultural practices. The future of agronomy will be shaped by the need to adapt agriculture to climate change, resource limitations, and evolving consumer demands. By developing resilient crop varieties and promoting environmentally responsible farming methods, agronomists contribute significantly to global food systems and sustainable development.
Agronomy. C1 level.
Agronomy is a highly specialized discipline within agricultural science that integrates biological, environmental, and technological knowledge to enhance crop production and ensure the sustainable management of natural resources. In the context of a rapidly growing global population, climate change, and increasing pressure on agricultural systems, agronomy has become essential for maintaining food security and promoting long-term environmental sustainability. One of the central objectives of agronomy is to optimize agricultural productivity while minimizing ecological impacts. Agronomists conduct extensive research on plant physiology, soil science, genetics, and environmental factors to develop innovative farming practices that improve crop performance. Their work enables farmers to maximize yields without compromising the health of ecosystems or the fertility of agricultural land. Soil is one of the most valuable resources in agriculture, and its preservation is a major concern for agronomists. Soil quality directly influences plant growth, nutrient availability, water retention, and overall productivity. Through detailed soil analysis, agronomists can identify deficiencies, recommend appropriate fertilization strategies, and implement conservation measures designed to prevent erosion and degradation. Sustainable soil management is critical for ensuring that agricultural land remains productive over the long term. Water resource management represents another key area of agronomic research and practice. Agriculture accounts for a significant proportion of global freshwater consumption, making efficient water use a priority. Agronomists develop advanced irrigation systems and water-saving technologies that allow farmers to increase productivity while reducing water waste. Precision agriculture techniques, supported by digital technologies, enable the accurate monitoring of soil moisture and crop requirements, leading to more efficient resource allocation. Crop protection is also a fundamental component of agronomy. Agricultural production faces numerous threats, including pests, plant diseases, invasive species, and extreme weather events. To address these challenges, agronomists employ integrated management strategies that combine biological control methods, resistant crop varieties, and environmentally responsible agricultural practices. Such approaches reduce dependence on chemical pesticides and contribute to the preservation of biodiversity. Technological innovation has transformed the agricultural sector in recent decades. Modern agronomy increasingly relies on sophisticated tools such as remote sensing, geographic information systems, GIS, artificial intelligence, machine learning, and unmanned aerial vehicles. These technologies provide valuable data that support evidence-based decision-making and improve the efficiency of agricultural operations. As a result, farmers can respond more effectively to changing environmental conditions and market demands. The future of agronomy is closely linked to global efforts to address climate change and ensure sustainable development. Rising temperatures, changing precipitation patterns, and the increasing frequency of extreme weather events present significant challenges for agricultural production. Agronomists play a crucial role in developing climate-resilient crops, improving resource use efficiency, and promoting sustainable farming systems capable of adapting to future conditions. Ultimately, agronomy extends far beyond the simple cultivation of crops. It represents a scientific and practical framework for balancing agricultural productivity, environmental stewardship, and economic viability. By combining scientific innovation with sustainable management principles, agronomy contributes significantly to the well-being of societies and the stability of global food systems.
Agronomy. C2 level.
Agronomy constitutes a sophisticated and interdisciplinary domain of agricultural science concerned with the optimization of crop production systems, the stewardship of natural resources, and the long-term sustainability of global food networks. As humanity faces unprecedented challenges associated with population growth, climate instability, biodiversity loss, and resource scarcity, agronomy has emerged as a pivotal scientific discipline at the intersection of environmental resilience, technological innovation, and food security. At its core, agronomy seeks to understand and manage the complex interactions between plants, soils, water, climate, and human activities. Agronomists employ advanced methodologies derived from soil science, plant physiology, genetics, ecology, biochemistry, and data science to develop integrated agricultural systems capable of maximizing productivity while minimizing environmental degradation. This systems-based approach reflects the growing recognition that agricultural sustainability cannot be achieved through isolated interventions, but rather through the careful management of interconnected ecological processes. Soil health remains one of the foundational pillars of agronomic research and practice. Beyond serving as a medium for plant growth, soil functions as a dynamic ecosystem that regulates nutrient cycling, carbon sequestration, water filtration, and biological activity. The degradation of soil resources through erosion, salinization, compaction, and nutrient depletion poses a significant threat to agricultural productivity worldwide. Consequently, contemporary agronomy places considerable emphasis on regenerative soil management practices designed to restore ecosystem functions, enhance resilience, and maintain long-term fertility. Water resource management represents another critical dimension of agronomic science. Given that agriculture accounts for approximately 70% of global freshwater withdrawals, improving water use efficiency has become an international priority. Agronomists investigate innovative irrigation technologies, precision water management systems, and drought adaptation strategies aimed at sustaining agricultural production under increasingly variable climatic conditions. Such efforts are particularly important in regions vulnerable to water scarcity and prolonged periods of environmental stress. The protection of crops against biotic and abiotic threats constitutes a further area of agronomic specialization. Agricultural systems are continually challenged by pests, pathogens, invasive species, nutrient imbalances, and extreme weather events. Modern agronomists increasingly advocate integrative management frameworks that combine genetic resistance, biological control agents, ecological diversification, and predictive modeling. These approaches seek not only to enhance crop resilience, but also to reduce dependence on synthetic chemical inputs, thereby promoting environmental integrity and public health. The digital transformation of agriculture has fundamentally reshaped the scope and capabilities of agronomic practice. Technologies such as remote sensing, geographic information systems, artificial intelligence, machine learning algorithms, autonomous machinery, and big data analytics enable unprecedented levels of precision and decision support. By leveraging these innovations, farmers can monitor crop performance in real time, optimize resource allocation, and respond proactively to emerging challenges. The integration of digital technologies into agronomic systems is widely regarded as a cornerstone of future agricultural development. Looking ahead, the strategic importance of agronomy is expected to increase substantially. Climate change is altering temperature regimes, precipitation patterns, and the distribution of agricultural risks across the globe. Simultaneously, growing consumer expectations regarding food quality, environmental responsibility, and supply chain transparency are transforming agricultural priorities. In response, agronomists are developing climate-smart agricultural systems, resilient crop varieties, and sustainable management strategies capable of balancing productivity with ecological stewardship. Ultimately, agronomy transcends the traditional objective of maximizing crop yields. It represents a comprehensive scientific framework for addressing some of the most pressing challenges facing modern civilization. Through the integration of ecological principles, technological advancements, and evidence-based management practices, agronomy contributes not only to agricultural productivity, but also to environmental sustainability, economic stability, and global human well-being. Thank you for watching. If you enjoyed this video, don't forget to subscribe, like, and stay tuned for the next lesson. Keep practicing and improve your English step by step.